Okay. Okay. Good afternoon. Right. So today, we want to do our final topic, IoT. Okay. IoT. Right. So I will be using a simulator, ThinkCard, but you can use if you have a physical, uh, digital electronic set. You can use your physical digital electronic set as well. Right. So let's move on. So first, you need to get an understanding about what is digital electronics. So at the same time, you must have a little bit of understanding about the applications of IoT. Uh, Last year there was a question. Okay, I think last 2 years or maybe last year there was a question, and also there are MCQs. Okay, there are MCQs. Uh, so if you understand it, this is not difficult. But if you don't understand, this is very difficult because this is more practical subject. Okay, right. So I will explain it slowly. So we will look at the introduction to IoT, the basics of electronics, introduction to Arduino environment, some example applications. Okay, right. So what is IoT? So remember, so in this world we have humans. So similarly, we have computers, and there are some other non-computer devices. Right. So we just call it things, and we can communicate as human to human communication. And we know that computers can be interconnected. Computer networking, we did a subject, computer networks. So computers can communicate with each other, right? And of course, humans can communicate with computer using user interfaces and so on. Say someone go to the e-banking system and do a money transfer. Go to the bank and withdraw money using ATM machine. ATM machine is a computer. So that means humans can communicate with computer also using user interfaces. So then what about the other things? Of course, we don't think about manual things like knives, brooms, and so on. We don't talk about mechanical things, but there are some other electronic or electromechanical things, and we commonly call them things. What are those? Electronic or electromechanical or anything related to electronic. If there's electronic component, so why can't we connect to this? Computers. And through computers, humans. Of course, humans can also communicate. But forget about this. If we can let these devices communicate with each other, non-computing electronic devices, so electromechanical devices communicating with each other is called Internet of Things. And we can use Internet also. So these devices are connected to Internet, and through Internet, or when I say Internet, it can be Internet or local area network, wired, Wi-Fi, whatever the way. So then you call it Internet of Things. And of course, the concept of Internet of Things, we can even combine computers as well because computers are also things. Okay. So things are getting more and more smarter. That means that things are getting more and more electronic things. So when they're getting electronic, then we can let them communicate with each other through networks, internet. And also we can connect our computer networks also to that. So then we call it Internet of Things. Okay. Right. So what is Internet of Things? IoT, connecting everyday objects embedded with sensors, software to the internet to make them smart by enabling communication with each other, central systems or people. Thereby we can automate and take data driven decisions. So that means the things are getting more smart. because they can communicate with each other and they can be connected to other central systems and so on. Okay. So that is called Internet of Things. So things are there. But when we say things, there must be some connection to electronics. Otherwise, we can't communicate with those or they can't communicate with each other. So these days, even the fridge, we can connect to internet. Obviously, now vehicles are connected to internet, right? Most of the electrical vehicles, they are all connected to internet and they get the updates. We can integrate with other things, door control systems and so on. And we use sensors and actuators inside those things or separately. So sensors can receive signals or changes in the environment can be detected by sensors, and actuators can do certain things like closing, opening the door, running the fire alarm. And of course, we need connectivity so that these things can be interconnected and then can be connected to internet. So things, sensors, actuators, connectivity. Okay. So then there can be some data processing also. These are not just electronic devices. We can have some data processing, microprocessors or microcontrollers where they can run programs. So that is where the things are getting more interesting, smart. And even now we can integrate with AI. And of course, by doing those, we can do a lot of automations. So my vehicle communicate with the door controlling system and door opens without my control. Now there are self-driving cars also, right? So the car can drive itself. So more and more automations happening. Okay. For example, we can integrate a washing machine such that when the washing machine is operation is over, it's connected to internet. So it's connected to other communication. It send a SMS to the relevant person. So right, maybe he or she is not very near the washing machine. Now he or she knows that okay, the washing machine has finished. Now I can take the cloth. So likewise, things are getting more and more smart because of Internet of Things. These are not theory, these are practical things these days. Okay. So the usages of IoT includes obviously smart homes, smart cities. We can use heavily in healthcare. Wearables can be used. And there's something called Industry 4.0. So that is make a lot of industrial activities, machineries and so on communicate with each other. Automate some regular maintenance and that kind of tasks. Introduce robotics. So those are all the practical usages of IoT. Okay. Right. So only thing is it must be a thing, not a computer, and there must be some electronic part so that it can communicate with each other, connect to internet, right, process, and so on. So then now we talk about another concept called Internet of Everything, IOE. Remember, Internet of Things is things communicating with each other and those connecting to central systems through networking, internet, and so on, so that they can collaborate. So that is Internet of Things. And of course, these things may include even computers, computer networks. But now we talk about Internet of Everything. So that means we include uh, not only the smart things, we include the computer networks, and definitely we include humans. So we all interconnected. We all collaborate, communicate as one thing. So human communicate with computers, humans communicate with things, send the messages to humans directly. So then we say Internet of Everything. Actually, now we are into the Internet of Everything as well. Because it includes machine to machine, people to machine. The machine can be computer or any other thing, smart thing. Okay. Is it clear? Right. So that is what IoT and IoE is. So that's it about IoE. Right. So we can use it in household activities, industrial activities, office automation. So basically do things in a smarter manner. Okay, this is the future, this is the present. Right. So now we move on to basics of electronics because this subject is actually electronic subject. Rest of the stuff is heavily technical. Okay. Right. So I will do it fast because this is your last subject and you guys are now very matured with all the other subjects. Okay. Programming we have done, web development done, database done. Okay. So now you guys are no longer kids, you guys are adults, right? Some right close to 90s, 19. Exams are nearing, right? So therefore I'll be doing very, very fast. Right. So remember, electronics is different from electrical. So electrics is convert electrical energy into heat, light, or mechanical power and do something useful. So that is electric. But electronic is either generating signals, receiving processing signals, or transforming signals. So these signals have meanings. It's not just conversion of power. This is more about signals. Signals carry some information, meanings. Generating signals, receiving signals, processing signals. That means change the signals from one form to the other. That is called processing. So that is electronics. So computer is a digital electronic device. Calculator is electronic device. Radio is electronic device. Of course, electricity is used one for the power, but then it's all about generating, receiving, processing signals. So computer is an electronic device, digital electronic device. So there are two types of electronics, analog electronics and digital electronics. Analog electronic devices use analog signals. Digital electronic devices use digital signals or discrete signals. So normal radio is an analog device. Normal telephone is an analog device, whereas computer, calculator is a digital electronic device. So when we say digital electronic device, we almost all the time refer to binary digital electronic device. So rather than having multiple levels, we have settled to two levels, right? So analog electronic, these things get gradually changed, but here all of a sudden it changed one to zero, zero to one, no, high potential, low potential. So modern digital electronic is binary digital electronic, mainly because maintaining two state is simpler and these signals are mainly processed by Boolean logic. Boolean logic is two state. So because Boolean logic is two state, the signal is also two state. So then it's very highly compatible, easy to process. Since I'm doing fast, if you have any questions, you need to ask. Okay. So as I told you, the binary digital electronic has sort of advantages compatible with Boolean logic because Boolean logic is also two state. Can be stored easily, binary concepts, ones and zeros, magnetism, right? And so many concepts, charging. And fixing errors due to noise is simpler because there can be corruptions, right? So initially your signal is like this, but due to some issues, maybe signal has changed like this. So this is change. But these kind of things can be easily detected and fixed when it is comes to binary digital electronics, just two state, right? Like parity bits and so on. And also we can easily modify your program. So program means the digital signals getting changed based on some logic. So that is what happens, right? When two signals going through AND gates, you get a different digital signal, right? When both are one only one, we have already discussed. Super simple concept, but very effective. That is why everywhere we talk, we like digital electronics. Analog electronics, we don't like much because when there's a small distortion, you can't 100% restore it because it's analog concept. So that is why we try to get away from analog electronics as much as possible and go into digital. But there are some limitations. So the biggest issue is we cannot send digital signals long distance, especially through air. Radio signals you are not digital. That is the biggest issue. So therefore, even though computer is almost 100% digital, when it comes to networking, we need to convert it to analog and transmit through air, radio waves. Radio waves are always analog, right? So the electromagnetic waves are also analog. Short distance, we can send digital signal like electricity up, on, off, but not very long distance. Okay. So this is the biggest issue with digital electronics. Difficult to transmit as electromagnetic waves. So this kind of waves you can't transmit long distance. Okay. Right. So these are the basic digital electronic elements, the very ABC elements. Resistors are there, LEDs are there, battery for power source, connector wires, ICs, circuit prototyping utilities like breadboards. Okay. So this is a battery, 9-volt battery. So 9-volt batteries have a little bit more power than the normal pentorch battery. This is a breadboard. I will explain each and everything. Okay. So this is the battery cap that you can fix it to here so that you can take wires like this because we can then fix wires. This is a LED bulb. You can see one side is longer than the other. It's a bulb with different colors. Resistors, and these are the jumper wires and other wires. Right? These days we don't need these needle pillars much because we have the breadboards and uh, connectors. Okay. So about 20 years ago, we used to solder. Electronic is all about soldering one wire to the other wire. It's a headache, but it's no longer the case. Anyone can now learn electronics very fast. Of course, electronic subject is difficult, but you don't need to mess around with, right? Bulbs, lead, soldering. No, you don't need to do it anymore. Okay, unless you manufacture something. Right. So this is our play toy breadboard, right? Breadboard because we can fix our elements. These kind of things have fairly strong pins. We can fix them into these holes. So then you don't need soldering. Okay. So I told you that this is a practical subject. So if you want to do it in a real practical manner, what you need is, right? I hope some of you guys may be having these. So that is what you need is Arduino pack. Right? If you do a Google search, Arduino pack. Say online by something like these sites. You can find which one is more cost effective. So rather than you buy these things individually, the better thing is uh, you buy pack of those things, something like this. You can see Arduino learning kit for beginners, schools, and universities. Right. So there are different price. packs. Okay. I think, what about this one? Some of you may be already having that. Okay. I'm pretty sure. Like something like Arduino starter kit. You can see A-level ICT project starter kit for school category. So this 6,290. So there can be some other variation like 5,900 to 6,990. Right? So this 3,190. So you just need a very basic pack, right? Very basic pack. Uh, so these packs are good enough. Okay. Of course, if you want to go into the serious robotics and so on, buy something much more complicated. But so these are most of the time good enough. Okay. But when you buy a pack, check what are the elements available. Okay. For example, what about this? Uh, so this include Arduino Uno. So Uno is the bigger, good size Arduino circuit. I will explain it about that. So don't go for this micro size Arduino circuits. Those are very tiny. Those are very cheap but very tiny. So make sure when you buy a particular pack, okay, uh, it contains Arduino Uno, right? So then it has the USB cables, a breadboard, okay, jump 20 jumper wires, right? Then four push buttons, five LEDs, red, yellow, green, blue, photo light sensitive resistor, some more resistors, like 10 number of 1K resistors, 10K resistors, 220 ohm resistors. So we need these, right? And 9-volt battery that I just showed you with battery clip, uh, and some more LED anodes. So this is very basic thing, right? Very basic thing. I don't recommend this one. Actually, you need few more uh, sensors if you want to do a little bit more serious stuff. But anyway, this is also uh, it's also fairly okay, right? But I think let's check something like 8,000 page. Yeah, probably this one should have more widgets, right? So check whether you have the Uno, right? So this one push buttons, pretty much the same thing. Resistors, rectifier diode, magnetic reed switch with magnet. Yeah, buzzer is there. You can see this one has little bit more features. Okay. But of course, other things you can buy separately also. If you need something, you can buy separately. Okay. So that is another option. You just buy the basic thing, but make sure it has a Uno set and something like 400 tie point breadboards. Okay. Then you can get it other things from electronic shop. Okay. Right. Right. So let's get back to our discussion. Uh, but again, it's not a must also, but it's always good to have those physical set of things. Okay. You can do it 100% virtually also. Don't worry. There are so many possibilities, but if you can do it hands on, that is always better. Okay. Because this is a practical subject. Right. So let's get back to our discussion. I'll come back to this again if we need. So this is called a breadboard. Right. So breadboard, it's made of solid thing, but you can uh, fix LED bulbs, transits, LED bulbs, resistors, and so on into these holes. When you fix it, it tie up. So why is it getting tie up? Because it is something like this. And something like this. So when you fix it, it keep attached to that until you take it out. Okay, so therefore it's very easy, right? So you just need to put it into these things rather than soldering. Okay, and this is how it looks. if you don't need to remove the outer cover, but if you remove it, it looks something like this. It looks something like this. So these are the two power lines. So these holes are connected like this, and these set of holes are connected like this. And other side also we have similar arrangement. So that means if you connect electricity to this hole, you get all these holes have the electricity. If you connect the electricity to this hole, second line, all the holes in that line has electricity. So other side also like that, but these are not interconnected. So that means you need to give electricity to this side or this side. If you need both, you need to connect this to this using wire. So then when you give electricity here, everywhere in this line and this line has electricity. If you don't understand it, let me know. I can explain it again. Okay. Right. So therefore, these are connected like this. This line is separately connected, but these two lines are not connected. And this line is interconnected inside using copper stripe, and these holes are interconnected. Okay. So therefore, if you give electricity to this hole, then all these holes have electricity in this line. And if you connect this hole with this hole, right, this hole, then all these having the electricity and all these also having electricity because these are again connected. So usually these are marked with plus and minus. So usually we give plus to this, minus to this. Then this line has the positive voltage. This line has the negative voltage or the ground. Right? So then you can work with this side. But then you can connect these lines into these cross. And these rows are connected like this. Now these are connected like this, but these are connected like this. Okay. So therefore, if you connect something here, if you need the electricity, say I will erase everything. Now, if you have electricity here, so then maybe you can connect this to this. So then this line has electricity. So then if you have bulb or something, you connect this and maybe this, your bulb. So then this line has now it's going like this through your bulb. Then it comes like this. Maybe you can connect this to this. And this is to the ground or negative. This is to the positive. Now this bulb is light. You just connect like wire to here, another wire to here, bulb, and then another wire to here, and then this is to negative. Then the circuit is complete. Okay. Do you have any questions? Okay. So remember, these are connected like this internally. These rows are connected like this internally, but these are not interconnected. Okay. Okay. So these are connected like this, each and every of these. But remember, this is not connected to this. Just these are connected. Just these are connected. And other thing is, this is not connected to this. So don't think that these are all connected. No, these are this side, right hand side is independent of left hand side. So when you give current to this line, only these things have electricity, but not here. Okay, because this is separated. It's like two boards, independent boards. Okay. So if you want, when you give current to this side, if you want this side also, then you need to connect these to these to this. Then only both lines have the electricity. Okay. So we call them power rails. Okay. So usually when we connect the positive sides, we use red color wires. Negative side, we use blue or black color. That is just a convention. Okay. Wire is a wire, but as a convention wiring, we use it so that we can better understand, better sense our circuit. Okay. So as I told you, this each and every hole, uh, you can fit a resistor or any other device. It will, when you push it, it will stick with that. Okay. So because every hole has a terminal stripes like this, it will lock it. Okay. And the middle part we can use to connect ICs and so on. Don't worry about that right now. Okay. So that is called dip. Right? We are not going to use dip right now. That means we can connect this and this side as well. Okay. But not in today's sessions. So these breadboards comes in different sizes, full size, half size, mini size, right? So usually half size is enough for you guys. Okay. So these packages, right? See whether they have package. This is another site. I don't promote any website or whatever, right? I just randomly search. Uh, right. So these are the individual things. This is a Uno board, but this is not a package. Okay. So you better go for a package, right? I don't know whether they don't. It looks like they don't have packages. Okay. Starter kits. Yeah, it looks like they don't have the starter kits. Okay. So can do a search. Okay. Right. So they don't. They also have electronic. No, not the packages, right? This is another basic package. Okay, package kit. I think this one has more items. Okay, this looks like it is having more items. But just double check what are the available. You can see Uno, right? Breadboard, 8, right? Large size breadboard, and so on. Okay. I think you can customize those and then remove items. Okay. Then remove items. Right. So if you still don't understand breadboard, so you go to the YouTube and search, right? How breadboard work. Anyway, I'll give you those links also, right? How a breadboard work. So they will show you even the internal structure of a breadboard. You need a bit of a learning curve if you are absolutely new. Hi, this is Ben Video with Science Buddies, and this video is all different shapes. So if you worry curious about why do we call it breadboard, before this concept of breadboard came, right? Kids have had used breadboards, the board that we use to uh, cut breads to build circuits. So that is why the word breadboards are used, right? But no longer you need actual breadboards. This is good enough, okay? You don't need this breadboard. This is good enough now, okay? Because now we can fix everything here, okay? Hi, this has been more complicated circuits. For example, like use wooden board. Modern breadboards are made from plastic and come in all shapes. I will share this. Make sure you go through this, okay? After the class, it will explain A to Z about what is a breadboard is, okay? A to Z. Sizes and even different colors. The most common sizes you'll probably see are full-size breadboards, half-size breadboards, and mini breadboards. Larger and smaller sizes are available, and many breadboards come with some breadboard allow you to easily push the leads or metal lid. See how to fix it? This LED, even
that will lightly hold them in place. This connection is strong enough that the LED won't fall out on its own, but light enough that if you make a mistake, you can easily pull it out and put it in a new location. Technically, these are called solderless breadboards because they can make these connections.
Okay, so make sure you go through this, okay? You can see how it is inside.
Outside.
Everything is explained.
Because to a jumper wire.
So this is how you fix it to a battery.
Demonstration circuit with a battery, a resistor, and an LED. When I turn the battery pack on, the LED lights up. Pretty simple. Now let's zoom in and see how I actually have everything connected on the breadboard. The battery pack's red lead is connected to the power bus on the right side of the breadboard. This is connected to a jumper wire that goes to row 5, which then goes to the LED, over to row 5 on the other side, to a resistor, to the
you can see circuit is complete through the battery.
This diagram shows how electricity flows through the circuit using yellow. Take the LED over to the right side. Here we have the demonstration. Right, so once you know the theory, it's super easy, okay? It's super easy. You can do it by yourself because this is, kids can even understand how it works, right? But only thing is you need to understand the ABC of electronics, electricity, okay? First. Now that is why I keep asking, have you understood? Have you understood? Right? So if you don't understand, straight away ask that or put it into chat, okay? Right. So the most important thing is you need to understand that these breadboards are internally connected like this. This line is connected like this. This line is independently connected. This is independently connected. This is independently connected, and these are connected all like this from, but these are not connected. These rows are not interconnected. Okay. So this is the most important thing that you need to keep it in mind. Right? Why they have arranged it to make your life easy. Right? Less connections. Okay. Less connections. It's a smart concept. Okay. So usually the positive, you can actually, there's nothing called positive and negative. It's all convention. Okay. If you want, you can consider this one as negative, this one as positive because wire is wire. But try to use the convention. Usually we use red for positive, black or blue for negative. And if they mention as a convention, take this as positive, just use it as positive. So then no confusions. Okay. And this side also you can say positive and negative. Positive and negative. So then make sure your battery side, you take the positive side here, negative side here. So then no confusions, right? It's all very neat. Okay. So this is connecting this side into this so that when you provide current here, now current is available not only this line, it is available in this line as well because this is connected to this. Okay. Okay. Right. So this is the simplest circuit you can make using a breadboard. Right? This is not rocket science. So look at, see whether you can see the circuit now. So red side is positive, okay? This is negative. So electricity comes from here to this. You can see. And remember, these are interconnected. So therefore, it comes like this and go through the resistor. Remember, these are interconnected like this. So therefore, electricity goes to this. And of course, electricity goes all the way to this line, but there's no item connected. So then it goes through the LED, come to this. And remember, these are interconnected like this. So therefore, electricity comes here. And we have another jumper wire, small wire connected so that it comes here. So then this is connected like this. So then it is the positive side. So sorry, the negative side or the ground side. So the loop is completed. So therefore, LED will be lighted. So this should be your first exercise, right? You just need the breadboard, one resistor, one LED, and 9-volt battery. Nothing else. So don't worry, these batteries are not going to give you electric shocks. So nothing to worry about your safety.
This is DC current. 9 volt is nothing. And you will never ever get shocks, electric shocks, because we are not going to use AC current. Right? If you have any doubts. So when it comes to batteries, you have the positive side and negative side. Right? You have the positive side, negative sides. Often these 9 volt batteries, those are marked. If not marked, red color is your positive side, black color is your negative side. Okay. Red color is positive side. Okay. And black color is negative side. Okay. And also the battery itself also it is marked most of the time. Right. So that is battery. Right. We don't need much use of batteries later on because we can get power from our computer also to the Arduino board. So therefore, through our USB cable. So therefore, anyway, we are not going to use batteries much. But anyway, this is how you start it. Okay. This is how you start it. So therefore, just start with battery, LED bulb, resistor circuit. So then we have resistors. So what does resistors do? It resists the electricity. Right? So if you want to reduce the current flow, use a resistor. Sometimes, for example, these LED bulbs, so they need only tiny electricity. If you give the just 9 volt voltage, the LED get burn out. So then always when we connect LED bulb, make sure you use together with the resistor of the specific resistance. Don't worry, I will tell you what are the resistance values, suitable values. So resistors comes in different resistance values. That is why your starter pack has about 10 to 20 resistors. So those resistors are of different resistance. Okay. So if you take this particular starter pack, okay. So you can see here, 5 1 kilo ohm resistor. That means 5 number of 1 kilo ohm resistors. 5 number of 10 kilo ohm resistors. Right. 2 number of 220 ohm resistors. Right. You can see set of about 12 resistors are there. Because we need different resistors, different or resistors with different ohm values. So this one has only 1 kilo ohm, 10 kilo ohm, 220 ohm. Most of the time, we connect 220 ohm resistors with LED bulbs. Okay, so this is the resistor we use mostly, 220 ohm resistor. These are kilo ohm level, 1 kilo ohm, 10 kilo ohm. Don't worry, I will explain all these things if you have forgotten these things you have done in your level. Okay. Right. So resistance is measured in ohms. Right? So resistors will resist to the current. So thereby, whenever you introduce a resistor, uh, it limit the current, reduce the current. If you want to further reduce the current, add higher resistance. Rather than 220 ohm, add 1 kilo ohm or add two resistors in serial. So then 220 plus 220, 440 ohm resistors. Okay. When it comes to resistors, there's nothing called positive and negative. It's just like a normal bulb. Normal bulb, there's no positive, negative, right? You fix it whatever the way. Resistors also, there's no positive, negative. You can just fix it whatever the way. But LED bulbs, there's a positive and negative. LED bulb and some other devices. But resistors, you just fix it, whatever the side you want. Okay. Right. So when you work with physical resistors, how do you identify? Because resistor is a very tiny device, it's very difficult to print what is the resistance. And also if they print it like say 220 ohms, there's a high chance it get uh, erased because you touch it, right? There's a high chance you get erased. Maybe this is erased, then you don't know whether it's 22. Okay. So therefore, when it comes to resistors, they use color bands because color band is more durable because it is the color is in the entire circumference. So how do you read the resistance? Because if you use physical resistors, you must know how to read it. So this is how you do it. Every resistor will have four color bands, sometimes three, sometimes four. Sometimes only these three, but most of the time all four. So you need to use this kind of a table, right, to read. So usually if you take a pack of that Arduino pack, starter pack, usually your starter pack will have this card where you can look at the colors and read the resistance. Most of the time that card Arduino pack will have this card also. Okay, electronic pack. Right, how do you read it? It's very easy, right? So this is your first figure, second figure, third figure, fourth figure. This gap is there, so that means this is the fourth one, right? Because if you look at it from other side, make sure you rotate it so that the three items are left and the other one is isolated in the right. Otherwise, you will read it in a wrong manner. Okay. So what about this one? So this one is first figure is this color. So this color is 1. This color is 1. So therefore now we have 1. The second color is black. Black means 0. So therefore we have 0. Then it is 10 to the power. And this color is your power. So this color is what? 3. This color is 3. And therefore this is 10 to the 10 into 10 to the power 3 ohm. So that is 10,000 ohm or 10 kilo ohm because 1000 ohm is kilo ohm. So this is 10,000 ohm or 10 kilo ohm. So this is not much important for us. This is the tolerance because these resistors, they can't make it 100% accurately, right? So this means the tolerance, plus or minus tolerance. So this color is yellow. Uh, so yellow means now you need to use this column to read only this band. And the tolerance is yellow means plus or minus 5%. That means 10,000 ohm with plus or minus 5% error. Okay, but usually we don't care about this. We just interested in these three. Okay, is it clear? Because when you work with physical electronic devices, your resistor will have these bands, color bands. They don't have the number. For the exam also, you must be aware of these things, right? How to read the resistance. So x, y into 10 to the power z plus or minus this much of tolerance. But tolerance, you need to read it from tolerance column. Others, you can read it from here. But this one is a multiplier, 10 to the power. But this one and this one is the same, 4 of 10 to the power 4. So this is basically 10 to the power x z. This is x, this is y, xy into 10 to the power z plus or minus, say this is t, t. Okay. Xy into 10 to the power z plus or minus t. But t you need to take it from this. Is it clear? Is it clear? At first color, second color into 10 to the power third color, tolerance is fourth color. That is plus or minus the tolerance. Okay. Because when you need to fix the correct resistor. Otherwise, when you connect LED, the resistance is too much, LED won't light. If the resistance is too little, the LED will burn out. So don't worry, LED will burn out, right? Not you. You are not going to get any issue. But then, of course, you can't use the LED because it's burned. Okay. So that is why whenever you connect LED with normal circuit, you connect 220 volt, 220 ohm resistor. That is why almost all the packs have 220 resistors. Okay. So here also you can see 220 ohm resistor. It is not a precise 220. Somewhere around 200 to 300 resistor will make your LED safe. Somewhere around 200 to 300. Okay. So usually we go for somewhere around 220, 230. So other resistors are when you build some other more sophisticated circuits. Right. Is it clear? Is it clear? Okay. I'm doing it very fast. That is why you need to ask question. Right. So that is resistor. So the second one is LED, light emitter diode. Right. Light emitter diode. So that is a bulb. It's a bulb, LED bulb. Unlike resistors, you have positive and negative side for diodes, LEDs. So you can identify positive side when you look at the physical LED. This side is longer. Longer side is positive for anode. Shorter side is negative for cathode. Okay. So if you swap it, you won't get this light. It won't burn it, but you won't get it light up. So make sure whenever you design a circuit, connect the longer side to the positive, shorter side to the negative. That is the only thing you need to remember. The second thing is always use a resistor. Right? Typically 220 ohm resistor. Usually we fix it to the positive side. Okay, positive side. So then only you give the power. Okay. Otherwise this may burn out. Okay. Right. So this is a small exercise. You can do it if you have the breadboard and other devices. You can use that, or else we can use a simulation environment called Tinkercad or any other simulation tools available. Okay, so that means either you can use uh, breadboard your battery and fix it like this, because you get these wires also as part of the. Of course, this is part of the battery. You just need a small wire. So these wires are available, right? These wires are available. You can just fix these wires, okay, in your pack, or you can separately buy these small jumper wires, right? So this is not rocket science, okay? You can do it within 1 minute, but make sure you read your resistance correctly using the color bands, which will you need bit of time, okay? So once you do that, in 2 minutes, in 1 minute, your circuit is working. But what I am going to do is I'm going to use a simulation environment, because now I have explained you the theory part, how to do it in practical manner. So it's your task to do practical, because this is not a physical class, right? But we will do it using a simulation environment, right? So, so there's a very famous simulation environment for digital electronics, that is Tinkercad. You can create an account without payments. It's free of charge. Okay. And then log into the system. Okay. So then you can go to circuits, create new circuit, and create this circuit. Okay. You not only that, we can even add Arduino board, Uno boards, right? And any other devices, even some actuators, speakers. Okay. Right. I will explain how to do it. I will explain how to do it in normal way. So the using ThinkCAD, but you better do it in using physical items. Okay, so this if you are doing it in physical manner without breadboard, this is if you do it with breadboard. With breadboard, without breadboard. Of course, without breadboard, you need to connect these things. This is not easy thing. Then you need to solder it or whatever, right? So that is why this is difficult thing. This is the easier thing, right? Just you need breadboard, two wires, because these wires are available from the battery, resistor, and LED. And I will explain how to do it using Tinkercad uh, simulation environment. Okay, simulation environment, but you must do it physically also. Both you must do it both physically and Tinkercad simulation environment. Okay, so this is our physical circuit. This is the semantic circuit, and this is resistor. This is the battery, and this is our LED. And remember, LED, this side, shorter side is negative, this is positive. But physically, the longer side is positive. Physically also, longer side is positive. Okay, positive. So don't change this. Then you will not get the lighting. Okay, I have explained everything. How to do it in Tinkercad, right? Because this is, of course, you can do it but now. And again, if you have any issues here, just go to the YouTube. I gave you the link. It shows how to do it physically also, right? How to do it physically. Once you get used to it, then you don't need any help. You can just do it by looking at the circuit. You can fix it. Okay, right. So let's do it using Tinkercad first. You need to log in. Okay. First, you need to create an account if you don't have an account. Tinkercad. I have account, therefore I will be automatically log in because I have account there. Okay. But you will not be automatically log in, right? You will get a sign up link. So then just sign up. You can just use your Google account, right? Or yeah, Google account, or you just create a username and password. Okay. You can just log in as they ask whether you are a student, teacher, or independent person. You can just say I'm a independent person. Okay. Right. So then once you do that, you log in, right? You log in to the system. If you are using your Gmail account, straight away you are done. Otherwise, you will get an email that you need to with the confirmation link. Right. So once you do that, this thing Tinkercad is not only for circuits, right? So this is for so many other type of designing activities as well, like 3D modeling, right? Code blocks. That is how you should kids learn programming visually. Right? We are not interested in code blocks or 3D. We are interested in circuits. Right? You can select circuit, right? And then you can say create. Okay, create. Okay. Again, it asks which one. Okay. So you can say circuit. So just follow these steps. Okay. That is after login. It's super easy. So now you just need to drag and drop the items, just like you do it physically. Whatever you do here virtually, you can do it in physically. Whatever you do physically, you can do it here. Right? If it works here, it works in physical environment also. Okay? So therefore, this is also good place to play around. Of course, if you have the Arduino pack, the best thing is use your Arduino pack. Okay, right. I will drag and drop a breadboard. Right, breadboard. If you want, you can rotate it. Okay, sorry, escape. Uh, if you want to rotate this, just select it and you can rotate it like that also. Okay. Okay, I'll keep it like this. Right. So then I will you if you want you can give it a name also. Right. What is the name? But I don't need to give it a name. I just call it by default it is one. That is fine. Now I will drag and drop a battery. So you can say this is 9-volt battery. So 9-volt battery is good enough. Okay. So that is our battery. Now I need to drag and drop. Just give me 1 minute. Hello, good afternoon. Hello. Okay, right, sorry for that. Okay. Right. So now I will drag and drop. First, I will give the power. Okay. Because this is virtual environment, you don't need to worry about getting burnout. Right. In physical environment, yes, you need to think about whether uh, your LED is going to be burned out. Anyway, let's do it in a proper way, just like in the physical environment. So first, I will add the LED. Okay, LED. So let's see whether we have LED here. Light emitter diode. Yes, LED is there. Right? You can just put it there. Later we can put it. Then I will drag and drop a resistor. Still, I have not fit it into the breadboard. Okay. Uh, then of course the wires you don't need to drag and drop. Wires automatically we can get it. Okay. Right. So first I will fix the. Now I will take the current to the rails. Okay. Current to the rails. So no, I will first connect the LED. So these LEDs, we need no point connecting like this and this because anyway these are interconnected. Okay. So therefore I will rotate this so that I can easily fix LEDs, right? Because or else you need to rotate the LED. Okay. So therefore I will rotate this board first like this so that I can fix the LED somewhere like this because no point fixing LED other way. Okay. You can fix it wherever you want. Okay. I fix it somewhere here. Okay. Right. So now you can see it is fixed to the this and this. Remember, there's a power. If connected, there's a power in these lines and there's a power in this line. But I have not connected any power. But just remember which is your positive one, right? So this is your bigger side, anode. This is cathode. Anode means positive side. Okay. Anode means positive side. So usually we connect resistor to the positive side. Right? No point connecting like this. Anyway, these are short circuited this way. So therefore, I will rotate this. Right? You don't need to read the band here because this is virtual environment. When you click, you can change the resistance. You can see it's kilo ohm. I will change it to ohm. And then I will say 220. That is because this is a virtual environment. But in physical environment, you need to read the bands and get the correct resistor. Okay. Because right. So now I will fix this to the positive side like this. Okay. You need to connect like this. Now what happens? This is, I have connected to the same vertical line because remember these are interconnected. So therefore now from resistor, electricity goes to the anode. Okay. And then it comes here, then electricity is here once you connect. Now I will connect the electricity, red to the red or positive and black or negative to negative. You can connect whatever, wherever you want, right? Because I will connect somewhere here. And I will use the colors also because this is the positive. I will change the color to red because then it's very neat. And this one is my negative side. I will use black. Now the current is here in this line. The negative side to ground is this line. Now I need to give the current. I want to give the current to this is the positive side. Remember anode. And anode is connected to this, but I don't give directly to this. Rather, I am going to give connect positive side to this. I can take it from whatever, wherever you want. It's not always from here because now electricity is in this line. Okay, I can use anything anywhere, but I will just take somewhere here. And then I need to give it to this one. Okay, I will mark it red also. Now what happens? The electricity goes like this. Let me open my pen. So if you are doing it physically, do the same thing, but with physical wires. Now electricity goes like this. Electricity goes like this. Then remember electricity goes like this because these lines are interconnected internally. Then it goes like this to this. Remember that now this entire vertical line has electricity. So therefore electricity is going like this. It goes through the resistance. Now electricity is in this vertical line. So therefore electricity goes like, of course electricity goes this way also, but there's nothing there. Then it goes through the LED bulb. Now we need to connect the LED bulb, its cathode to the negative side. So then we are done. Okay, then we are done. So therefore I'll click on this point and then click on this point. This is positive. Okay, so usually positive side, I prefer to mark it in black. Okay. So here you don't need a wire because resistor is connected here and there's a connectivity. Okay. So still you can't see any lighting because still my circuit is not started. It's not simulated. This is just it's like still no power. But now the circuit is okay. Now you need to say start simulation. And you can see it is now lit. If you stop it, right? Again start it. Right? LED is now working. Okay. And also if you want to reduce the uh, brightness, you need to uh, increase the resistance. For example, if I change it to something like 1,000 ohms, okay, then again start simulation. It's blurred anyway. Let me increase further. Something like, just double click on that. Okay. So why can't I get it? Right. So let's say it's 2 kilo ohm or 5 kilo, 4 kilo ohm. Now you can see it's very dim. It's very dim. It's lighting, but very dim. Okay. So I change it back to 220. That is the standard. Increase in the resistance won't harm your bulb anyway. In simulation environment, there's no harming, but physically also, only thing is it won't get enough electricity. Okay. Right now I put it back to 220. That is the recommended size. Right? So now it's fairly bright. Right. Any questions? Any questions? Okay. So always starting is little bit difficult, right? Once you start it, things are not that difficult. So therefore, so this is how the circuit goes now. It goes like this, goes like this, go through the resistor, go through the LED, comes here, and it comes like this and finish the circuit. This is positive, this is negative. Another name for negative is ground. Ground or voltage zero. Any questions? So if you do it in a physical breadboard and physical battery, you will get the same result. Okay. So this is the semantic diagram. This is the physical. Okay. Physical picture of the physical if you do it. So this is if you do it in Tinkercad, the steps. Okay. Right. Any questions? Right. Now I'm going to do a little bit of a uh, revision on electricity because we are working with electricity, right? Uh, Then I'll get back to this. Right, electricity basics. Of course, you should know these things, but just a tiny uh, 5 minutes revision to give you the confidence if you have forgotten very basics. Okay. So when it comes to electricity, there are two type of electricity. AC electricity, that is what we use in our day-to-day activities in household from CEB, Ceylon Electricity Board or whatever, we get the AC electricity. That is high power, dangerous to work with unless you know how to handle AC electricity. So there, it's alternative current. So current is a electric signal like this, right? Electric signal like this with specific voltage and specific hertz. Hertz is how many cycles per uh, second. I think in Sri Lanka it is 50 hertz and 220 watts volts. Okay, but in our subject we only use DC current. So DC current means it's not wave like this. It's current like this. Continuously it gives the same flow of electrons. By the way, electricity is flow of electrons. Okay, electricity is what? Flow of electrons. So if you have basically batteries, negative side means you have excessive electrons. Positive side, you have lack of electrons. So therefore, when you connect it using a bulb or something, electrons go through from negative side to the positive side. So this is where the electron flows, right? So that is why after when you use it for sometimes, the battery is no longer usable, right? You need to throw away and buy another battery because electrons have in the negative side has now drained because it has been used up. So this is the electron. So electricity is a flow of electrons. But when it comes to especially electronics, rather than you look at it as flow of electrons, we look at it as flow of positive charges from positive side to negative side. So this is called electron flow. But in electronics, we look at it something like other way. Okay, so we can think of it like rather than thinking that it is going from negative side to positive side, the electrons, we can think like electricity going from positive side to negative side. Right? Positive side to negative side, positive charges going. So that is called the normal electric flow. So therefore, normal electric flow, you can think of it going from positive side to negative side. But if you think about electrons, it goes from negative side to positive side. But in electricity and electronics, when we draw diagrams, most of the time we draw diagram going electricity flow from positive to negative. Okay, positive to negative. So just remember, and it's a constant flow because DC. Okay. And usually this kind of battery, it's not going to harm you. Even car battery is not going to harm you. Okay. Unless it's very special case. Right. You can't talk about electricity without talking about voltage, ampere or the current flow and resistance. So what is mean by voltage? So you have done these things in O levels. So voltage is difference in potential for flow of electrons. So you know that when there's a difference in potential energy, something like we fall from say I am here and someone is here. So this is a so when I come here, I go down because there's a difference in potential energy. So I will go from top to bottom, fall from top to bottom. Similarly, water also fall from here to here. In waterfall, right? High potential to low potential. So there's a tendency like that. So that is called potential. There's a potential difference. So when there's a potential difference, it flows from high potential to low potential, or it fall. So voltage difference is also like that. It's also potential, but its potential is, the difference is, here we have extra electrons, here we have lack of electrons compared to this point. So therefore, when you have high electron density and low electron density, electron tend to go like that. So higher the potential energy, higher that possibility. That means high voltage means there's a higher possibility of higher energy difference, right? But remember, electron flow from higher density to lower density, but we can think of it like positive charges going from lower to high. So this is a conventional electricity. This is real electron flow. Actually, in reality, it is electron flow. But you can see that higher the potential, higher the possibility of electricity, electron flow. But just because there's a potential difference, it doesn't, electrons cannot flow because there's a resistance. Resistance. Say this is high electron density, low electron density, but those two points are connected using plastic. So then plastic has very high resistance, therefore electrons cannot go from here to here. But if you connect to using copper wire or something, because copper wire has very low resistance, that what if you have high voltage, you can see high flow of electrons, so high flow of electricity. So therefore, these three are interconnected. Potential energy measured in volts, flow of electrons or flow of positive charges, that is elect current, and the resistance of the material you have connected the two potential differences. Material or any other device. For example, wires also have a bit of a potential resistance, but very low, copper wires. But if you fix a resistor, that gives fairly high resistance, which cut down a lot of electric flow. Even your diode, LEDs have very small resistance, but it is very small. But resistors have very high resistance, and it depends on your resistors value. Is it clear? Okay. So your voltage is something like this. You can see water tend to flow from here to here. Tend to flow from here to here. Because this is a high potential, this is low potential. This is water, not electricity. Water tend to flow naturally from this to this point. You don't need anything. You don't need pump to get water from here to here. And okay. And this difference is high, means high potential, potential difference. This difference is low, means low potential difference. Usually low potential difference means low current, low water stream. And when the water flow from here, we can get something done because there's a energy difference. So similarly in electricity, we can also do something that like lighting a bulb. So this analogy is very important. So then you can't take water from here to here, right? So you need a pump. So likewise, you can't take electrons from low density to high density. That is where you need a battery. So pump and battery, this turbine and your bulb or whatever. So those are the analogies. Okay. Those are the analogies. So this is now your pump is replaced by battery. Your turbine is replaced by bulb. And of course the small resistors so that your bulb is not get overloaded. And remember, here we always, in electronics, we consider that it is positive things going from this to this. But in reality, electrons go from here to here. But when we draw circuits and understand, we always think that positive charges going from positive side of the battery through this circuit to the negative side. Negative side, another name is ground. Power and ground, or positive and negative. So electricity goes from positive to negative, or positive to ground. Sometimes you get confused, right? Sometimes we use the word ground, sometimes we use the word negative. Okay. But both are the same. We use both the words. So ground means typically zero potential. But here you have potential. So therefore there will be a potential difference. That potential difference is your voltage of your battery. If you use 9-volt battery, potential difference is 9 volt. If you use 6-volt battery, the potential difference is 6 volt. So usually 9-volt battery can give you higher electricity flow than 6-volt battery. And if that electricity flow is too much for a bulb, you can introduce a resistor. Is it clear? So whenever there are electronic or electrical or electronic items in your circuit, there's a voltage drop. So if you start with 5 volts, after electricity going through this resistor, it's no longer 5 volt. The difference earlier, ground and this 5 volts. Now maybe from this point to ground, it is maybe 2 volts. So the okay. So when it goes through this LED bulb, maybe further the voltage difference is reduced because every item consume bit of voltage, reduce bit of voltage. Some items reduce it heavily, some items reduces only marginally. So higher resistance means higher drop of voltage. Lower resistance means lower drop of voltage. That is why if you don't have any item, just the wire, the drop in voltage is almost negligible. But still there's a negligible voltage drop because even copper wire has a very small resistance. Okay. So you need to understand the concepts. So then you are very comfortable. Okay. So if you want to check the voltage difference, you can use a multimeter and check what is the current voltage difference between those 2 points. Right. I will explain how to use multimeter also. Okay. So that is voltage difference or potential energy difference measured in volts. 9 volts, 6 volts. So then we have the concept of current, I, earlier V. So current is the flow of electric charges. Actually, it is electrons, but we consider it as positive things going opposite way. So higher current means there's a higher flow of charges. Low current means there's a lower flow of charges. So we measure how many charges going per second or amount of electricity flowing per second as 1 ampere. Okay, ampere. So higher the ampere rate, higher the number of charges flowing. So usually higher the voltage, higher the ampere. So that means I is proportional to voltage. Higher the voltage, higher the current flow of electricity. Okay. So remember when we have this kind of a proportionality, direct proportionality, we can get rid of this by introducing constant. So I equal that constant is called R because this depends on the material. For different materials, you have different resistance. Okay. So low resistance means, for example, when this is 5, if resistance is 1, I is also 5. When you increase it to 10, now voltage current is also 10. But if your R is high, so not I equal RV, V equal IR. Sorry, I made a mistake. Say V is proportionate to I. So then V equal R times I. Okay, V equal IR. Okay. Now if your R is high, say, assume R is low, R is 1. So then when this is 10, this may be 10. But if your R is high, like 10, now when this is 10, this is 1 because 10 into 1 is 10. You can see that higher resistance means low voltage. Lower resistance means higher voltage. Higher voltage means higher current also. So that means high resistance means it reduces your current. It reduces your current. Okay. To the same voltage, you get lower current. Same voltage. Say voltage is 1000. When you have low resistance, the I is, say R is 1. So then I is also 1000. But if R is 10, now I is 10 because 10 into 10. So sorry, if this is 10, this is 100, earlier 1000. Now you can see that when resistance is high, your current is going down. So you need to understand practically, not just like memorizing formulas. It is something like speed, distance, and time. You have idea about that, right? So higher the speed, lower the time. Higher the distance, higher the time. If you use the same velocity. But if you increase the velocity, you need lower time. So likewise, you need to understand, right? So remember there it is speed equal distance divided by time, or distance equals speed into time. Distance equals speed into time. Here we have V equal IR. Okay. This R is like this, I is like this. So here higher the distance, higher the time. Here higher the voltage, higher the I if you have the same resistance. But if you increase the resistance for the same voltage, you get low I. It's something like if you increase the speed, right? Increase the speed, you can go the same distance at lower time, right? Smaller time, because now you are going at higher speed. So just look at this analogy if you have any doubt, because you need to feel it. So you need to feel it, feel the subjects. So then you don't need to memorize. Some students, they don't feel it. They don't want to feel it. Rather, they want to memorize it without feeling the subject. Okay. So this is an example. So this is the voltage difference. Sorry, this is the voltage difference, and this is like potential difference. Okay, potential difference. So this is voltage difference. So the higher the width means what? Higher flow of water. Higher width is something like here smaller wire or smaller resistance. Higher width is something like smaller resistance. Smaller resistance means high electric flow, right? It's other way. So here the pipe is smaller means small flow. So pipe is small is something like the resistance is high. Resistance is high means lower current. So you need to understand this practically. Okay. So therefore, if you want to give lesser current, increase the resistance. Increase the resistance is something like making this pipe smaller. So then you get smaller water flow. Okay. So when we use with Arduino board, right? Arduino board, usually we work with about 1 ampere, right? 40 ampere, milliampere type of currents. So maximum input current for Arduino board is 1 ampere. So typically your Arduino board has pins, input output pins. So those pins will give you about 40 milliampere current, which is very tiny, very tiny. Okay, 40 milliampere current. But it can take about 1 ampere current from your laptop or from external power source. If you get more than 1 ampere, your Arduino board will uh, not function properly. Okay, so usually from USB board, you will get the DC current that is always less than 1 ampere. Therefore, you don't need to worry about uh, burning out of your Arduino board. Okay, when you connect to the USB port, your laptop, don't worry, you don't get more than 1 ampere. And your output pins from Arduino board, you don't get more than 40 milliampere. So therefore, you don't get any electric shocks as well. Okay. Right. So I will explain how to measure current. So if you have a multimeter, you can measure voltage difference, you can measure current, and also you can measure resistance. Otherwise, you need separate devices like voltage meter, ampere, and so on, right? So rather than now, these days, we have one device called multimeter. Using the multimeter, you can measure voltage differences, current flow, and not only that, the resistance between 2 points. So if you have a resistor, if you want to check actually what is the resistor's value, you can use the multimeter and check the actual resistance also if you have any doubts about the color codes. All these things can be done using multimeter. Okay. So I'll explain about how to use multimeter also. Okay. So resistance is a property of the material. Okay, so the materials like copper has low resistance, low ohm value. Materials like plastic has very high resistance, and in between like iron, moderate resistance. Okay, so you can see the resistance is something like, so this bigger pipe means low resistance. That means high flow. So, so this is bigger pipe, high water flow. Here, low resistance wire like copper means high water flow. High resistance wire like iron is low current flow. Low current flow. So you need to understand this. You need to understand this. Okay. Is it clear? Now you can see. So here one resistor, four resistor. Four resistor means assume these wires are not much resistance. So higher resistance means low flow of current. So therefore you can see this is dim, dull. This is very bright because just one, say if this is 100 ohm, now this is 400 ohm. Okay. So if you want to control the current, increase the resistance using resistors. Higher resistance resistor or add multiple resistors. If you if you don't have the highest ohm value resistors. So remember the ohm law, V equal IR. So that is how you relate voltage and current for a given material. For a given material or device, it has a fixed resistance. Fixed resistance. Okay. Right. So now we can come back to our discussion again. Just give me 1 minute. Okay. Right. So, right. So we did this example using Tinkercad. Make sure you do this using physical way also, right? If you have breadboard and everything. Okay. Right. So the next device we are interested is push button. Again, if you get physical set for the Arduino, definitely there will be push buttons. So let's see whether these sets have push buttons. So make sure now when you get it, make sure now you know what are the necessary things. Okay. Uh, you can see two push buttons. This package. So push buttons are switches. Right? Push buttons are switches. So when you push it, electricity flows. Physically push it, right? Just like bell switch, right? Bell switch. When you push it, okay. So electricity goes like this. When you don't push it, electricity cannot go from here to here. No electricity. So therefore, if you want to let electricity flow, you need to physically push it. If you use the physical push button, if you use simulator, the simulator has a functionality to push it. Using the mouse, you can push it. Okay. It's like on off gate. Gate is close means push. That is electricity flow. Gate is, if you haven't pushed it, gate is zero. Gate is not open. Electricity can't flow. Okay. Right. So usually you need only two lines, two wires to the button, right? But you push buttons typically have four lines. So why do you have four lines? Because you are going to push it physically, especially physically, right? Not virtually. When you push it, you will not be able to push it unless it is something like this kind of a two-dimensional. So therefore, they will have it almost all the push buttons will have four wires, so that you can fit it to four holes rather than two holes, so that you can push it firmly. Okay, push it firmly. But you just need to remember the how it works. So this is how it works. Okay. So basically, you can think of it like this. This internally how it looks. So internally, the electricity cannot go from here to here. And electricity, if you have given electricity here, it can't go to this side. But when you push it, it's both are open, both are closed. So that means when you push it, electricity comes from this side, can go from this side. When you push it, when you release it again, electricity cannot go this side. And it's like two switch actually. If you have electricity here, when you push it, now the circuit electricity goes like this. If you have electricity here, it can go like this. It's two independent push buttons. But most of the time we will use only one side. Okay, one side. So therefore, you don't usually use push button like this. This one and this one you don't use, because these are not, anyway, when you push it also, they are not going to connect it. So therefore, make sure you connect this and this, or this and this, not this and this, or this and this. Okay. Anyway, this and this is internally connected. Internally connected. So therefore, no point connecting this and this. Okay. But you can use this and this. When you push it, this is closed. Now electricity flows. Forget about this because no, you have not connected anything. You can use this and this, or you can use this and this. When you push, electricity goes like this. No, you have not connected anything here. Okay. Or even you can use this and this. This and this. Why? This is internally connected to here. When you push it, this is closed. Now electricity goes like this and goes like this. Right? Only thing is, don't use diagonally. Don't use this and this, because it is any always connected. But you can use any other combination. This and this, you can use this and this, you can use, and also you can use this and this, or this and this. But don't use this and this, because anyway it is always connected. Like push karat nadat aage one. Okay. So you need to understand. Right. So this is the same circuit with push button. push button. So now we have add a small push button to this one. Physically also the same thing. You just usually it's easy to add push button to this middle part because two pins from this side, other two pins from this side. Then of course we don't use this side. So now electricity goes like this. This positive side, there's no standard electricity going like this, going like this. If you haven't pushed it, electricity doesn't go from here to here. There's no electricity from this line to this line if you haven't pushed it. But when you push it, this gate is now closed. When you push it only, okay? So now when you push it, it goes like this, goes like this, goes like this, goes like this, and so. But that is only when you push it. When you haven't pushed it, electricity cannot go from here to here because this is connected to this. Remember, there's no connection like this. Only these are connected. Okay. Is it clear? Okay. So shall we introduce a push button to our demo? But make sure you don't add push button like diagonally. Right? No point. Then it is always on. So let's add a push button. You can see push button. And this is basic, right? There are some more items if you go to all, right? Other than these items. But this is the basic stuff. Because basic stuff you have the push button and everything, right? So let's drag and drop. Let's drag and drop somewhere here. Right. Okay. Right. Now I will give my positive electricity. I will give it to this anywhere here. Because now it goes like this and it goes like this. But when I push it only, this line has current. Right? This line has current. So then I will connect this to this. Okay. No, not this to this. Right? No, not this to this. Okay. So then from here, I need to connect to this. Right? From here, because now I have connected to this line. When you push it, it comes here. From here, I need to get it to here. So from any of these points, okay? Because now this line has current when I push it, because current goes like this. So therefore, I'll take from here, so, or any point, maybe to here. Okay. So now look at when I push it, what is the circuit current flow? We don't look at the electricity flow. We look at the positive charge flow. Uh, it goes like this. Goes like this. This is connected to this. So it goes like this. And when you push it, when you haven't pushed it, that's the end of the story. When you push it, it goes like this, goes like this, goes like this, then go through the resistor, go through the LED bulb, come to this power rail, and go to the ground or the negative. But that happens only when you push it. When you push it, only this is gate is open, gate is closed. So therefore, when I simulate, initially my push LED is going to be off, right? Anyway, I have not start the simulation, so therefore anyway it is off. But earlier when I start simulation, all of a sudden it start lighting, but this time it is not going to happen. Now you can see it's simulation has started, but no LED light is off. But now I can push it. Right? I can push it. Now you can see when I push it, current is there. Right? Current is there. When I release, no current. If you do it in physical way, same result. Right? Same result. Don't worry. Just take your push button and fit it. It will fit into this middle. Right? It will fit into this middle. Okay. So now you can see that it's working. Okay. So it's a switch. Okay. And I will stop it. But if you do something like this, what happens? Okay. Still no current, right? Yeah, it's the same thing. I thought maybe this is connected to this one, right? Maybe this is connected to this one. So that is why still no current. I need to push it, right? I need to push it. Let's see, because sometimes push buttons operate slightly differently. Let's see what happens if I connect this to this. I just curious. Now you can see without pushing also it is working because this connectivity is like this. Now without pushing also light is on. The reason is electricity goes like this. It goes like this. And even without pushing, this is connected to this. Even without pushing. So therefore it goes like this and comes like this. Right. So that means in this push button, this is connected to this. This is connected to this. So therefore, even without pushing now light up. But if I connect to this or this, it doesn't, it will act like a normal push button. Okay. So therefore I'll stop it. And I'll connect it the normal way. So usually you use the same side. Same side. Okay. Right. So now it should be working as a normal push button. Initially it must not have the current. But when I push, it should be working. Okay. It must be working. Got it? And if you physically wire it, you need these wires are available in your battery pack. You just need two wires. Don't worry if they are longer, don't worry. It's not issue. Even though you connect it somewhere here, it still it work because I need to stop the simulation. While it is simulating, you can't change. And still it is the same result. Right? When you push, it work. Okay. Right. Any questions? Okay. Right. Now you know how to work with LED. Make sure the positive negative sides are properly connected. Longer side is your positive. Always use resistor with somewhere around 220. Then how to use push button. Okay. Right. So when you now this is we are working with virtual environment, but when you work with real physical electronic components with your breadboards and real resistor and so on, sometimes it may not work, right? Maybe you have not fixed it properly because there can be loose connections because virtual world is easy. Reality is practical problems are there, right? Maybe your battery is drain out. It's not giving 9 volt. Maybe your wire is broken somewhere. Who knows? Who knows? Maybe your LED is not working. So you thinking that your circuit is not working. Actually, you are using a burnt LED. Or your push button is not working. So there can be so many things in reality. Right? That is why it's always easier to work in this kind of virtual environment to learn things fast. But you need to face the reality one day or the other, right? So therefore, it's always good to face the reality from the very beginning. Of course, this is because the online class I'm just using the simulator. Otherwise, I will also be using the real things, right? Right. So when you have that kind of problems, sometimes you need to troubleshoot. And also when you are doing some serious stuff, you need to design circuits also, right? Design circuits and you need to calculate what is the exact voltage you want to provide, how to reduce your current from that to this, how many, what amount of resistance you need to introduce and blah, blah, blah. So in that kind of situations, you need practical troubleshooting, calculations, actually measure and see whether are you getting the expected voltage, expected current, is that device has the expected resistance and so on. So that is where multimeter is very handy. Okay, that is where the multimeter is very handy. So multimeter is, as the name suggests, a multi-purpose meter. You can use it to measure voltage, current, resistance, and also you can use it to check whether there's a closed circuit between 2 points. That is called continuity test. Okay, continuity test. It's super easy. Super easy. Of course, every multimeter has slightly different look and feel, but overall, it's the same. Okay. So you will get the multimeter device and wires separate. So these are the edges where you can connect to or touch it to your electronic devices or your breadboard. Okay, so you can see we can fix it. It's very hard. And these 2 points you connect to these knobs or ports. So there are 3 ports, but you have two of these. How do you call it? Uh, Probes. Okay, so you need to connect to the correct slots or correct ports because there are 3 ports, 2 probes. Okay, and also there's a dial. You need to set it to correct uh, values depending on whether you want to measure voltage, you want to measure current, or you want to measure uh, resistance, or you want to just do the continuity test. And these days, most of the multimeters are digital. So this will display the values like, say, the ampere is say 1200 milliampere and something like that. 250 volt, okay, 130 ohm resistance. So this is this particular dial magnified version. So when it is in this position, your multimeter is off. That means it is not going to work. And here you can see voltage values, right? Voltage values up to this point, right? So 200 millivolt to 600 volt. So then it keep increasing also. But this is for DC voltages. This is for AC voltages. Anyway, we are not going interested in AC voltages. So you always, when you measure voltages, you will set it somewhere here. This knob you can rotate. You will keep it somewhere in this region when you want to measure voltage, right? When you want to measure current, you will put it somewhere in this region. Exact place, I will explain how to decide. When you want to measure resistance, you will put it somewhere in this region because you can rotate this, okay? It's like a dial. When you are doing the continuity test, you put it there. You put it there, okay? So don't use this because this is for AC voltage measurements. So this is when you measure voltage. This is when you measure current. This is when you measure resistance. This is when you do, that means this knob must be rotated to this point when you are doing the continuity test. I will explain what is continuity test, okay? So then how do you decide the exact value? So if you know that you are going to measure, your current is going to be somewhere around, say, 20 milliampere, because you have idea based on your Ohm's law and your battery and so on. I told you that Arduino will not give you high amperages. So that means you know that your board will provide only this much of, roughly this much of current. It will give you this much of voltage. So even your slots will have the voltage value. So if, for example, if you have connected 9 volt battery, so that means voltage is going to be somewhere around 9 volt, less than 9 volt. So then you can initially set it to something like here. Because when you set it to the correct or somewhere correct value, the sensitivity is high. Otherwise, you will get low sensitive results. when you measure about 5 volts, if you set it to something like 20 volts, your actual value will have errors. Maybe it's actually 5 volts, but you may get it like 4.5 volts. But if you set it to somewhere around 5 volts, because you have idea of maybe 5 volts or 8 volts or 10 volts or 4 volts, then you are going to get much more accurate value. So same applied for example, if you want to check resistance, now you know that that resistor is already 220 ohm. So then why don't you just set it to somewhere around 200 somewhere here? So then you will get the exact value. But if you set it somewhere here, actually it is 220, but your multimeter might say it is 250. So therefore, always start with the lower side, because if you go for the bigger side, sometimes it might burn your uh, multimeters, not the multimeters fuse. Then you need to add another fuse. Okay. Uh, so therefore, that is why we have ranges. So just you have idea about what kind of voltage, what kind of uh, amperage, what kind of resistance we expect. So just set it somewhere there, not exactly. So then your multimeter is much more sensitive. Okay. Other than that, that's it. And if you are doing continuity test, make sure you rotate it to this point. Okay. Right. Now I will explain how to measure. Uh, right. So then we have the two wires, but three ports. So we have the two probes, but three ports. So then you need to fix it to the correct ports depending on what you are doing. Okay, what you are doing. So, so this is your black probe. You remember you have black wire? Your black probe is always connected to the middle or COM. It may not be middle in some multimeters, but uh, something labeled as probe labeled as COM is your black wire. Black wire always going here. Okay, black wire is always your COM. So then your red wire, you can connect to either here or here. Okay. Here or here. Again, if you are measuring low voltage, low electricity, connect to here. If you are measuring somewhat high voltage, somewhat high electric current, usually high voltage means high current also most of the time, connect the red probe into this. That is how you decide. Okay. So what is the so black is always COM, right? And that is your ground or negative. So then if you are measuring smaller values, go for this one because it is marked, right? Microampere or microvolt or micro ohm. Okay? So not micro, milli. So then you connect to here because you are working with milliamperes level, millivolt level. Or you connect to here, that means your expected range is somewhere around 10 ampere, 20 ampere higher. Okay. So that is how you decide. Okay. Right. So then of course you set it to the correct area, whether you measure voltage, resistance or uh, current. Okay. Right. How do you measure voltage? It's super easy. So remember voltage is potential difference. So there should be a potential difference, otherwise you will get it as zero. Right. For example, if you take battery, the two sides, the potential difference is 9 volt. You can even connect these to the two sides of the battery and it will give 9 volt. But make sure you connect it to the correct probes and set the dial into the correct ranges. Okay. So that is how you measure the voltage. But there must be a genuine voltage difference, right? So of course, multimeter you may not you don't get a multimeter from your uh, that pack. Okay, so multimeters are used by when we are doing some advanced troubleshooting and so on, right? This is optional part, right? But this gives you the confidence, right? This gives you the confidence. Okay, right. So now we'll let's get back to our this one and see whether we can measure the voltage difference. Okay, so let's add a multimeter. So this is a multimeter, right? This is a multimeter. I will add it somewhere here. Now I want to check the voltage difference between this point and this point. Of course, it must be somewhere around 9 volt because there's a battery. Okay. So then again, this is the positive side. Red, I will red connect to positive. Anywhere here, okay? Anywhere here. This one I will connect negative to negative. Maybe, yeah, somewhere here. Okay. So then you need to tell what mode you are in. Voltage. Yes, it's all correct. Voltage. I want to measure voltage and I should get somewhere around 9 volt. Right. Now I'm going to start simulation. Right. Start simulation. And it says 9 volt. Because whether you push it or not, it is 9 volt. Right? When you push it, it's slightly different by now electricity. Earlier, electricity had to go through the multimeter. Now, electricity can go through this other circuit also. That is why it is slightly lower because voltage is now divided partly through the multimeter. Other part is going. There's a current flowing through the circuit also. Right? You can see 8.95. So exact value depends on the resistance values and so on. Okay. So that is when you want to measure the voltage. So make sure you connect it through a voltage where there's an actual voltage. And when you work with these virtual things, you don't need to work with these which ranges. You don't need to worry because this is simulation. Right. If you want to measure the current, you need to connect it serially because current need to go through your multimeter also. Okay. For example, if you want to measure what current go through this circuit, right, you need to put it in the serial manner. For example, now I'm going to delete this line wire. Oh, okay. Right. Control Z is working luckily. Right. So now remember this electricity goes like this, goes like this, and then goes like this. I will change this to this. So because I want to connect electricity going through this one also. So therefore I will change this. I will do it another 5 minutes, okay? Because I want to finish this. Just select it and I will take it to somewhere here. Now, of course, no electricity, right? No electricity, nothing. Even when I push button, no electricity because now the path is not connected. But now, if I connect this to this, electricity goes, right? This to this. Okay, stop. Say this to this, right? Now again, electricity flows when I click the push button. But rather than doing like this, I'm going to delete this line or remove this line and I'm going to connect my this point to this. So therefore electricity going through my multimeter now. Then this go to the push button. But now I want to change it to not voltage, amperage. Right, amperage. Now I can start simulation. No electricity flowing because I have not pushed it. Because this is open. Electricity can't go. Electricity cannot go through this. That is why the LED bulb is also off. But when I push it, LED bulb will light up because electricity flows and that electricity going through my multimeter also. Therefore, you will see there's an amperage. You can see 30.9 milliamperes. Okay. And again, it goes to zero. Right. So that is how you use multimeter to measure the amperage for the current flow. Then what about the resistance? So resistance, of course, you need to have a device with that resistance. right? There's no resistance between two wires, two part of a wire, okay? And you don't need current to measure that also because your multimeter will send a small current and measure the resistance, okay? So therefore now I'm going to explain you how to measure resistance. I will delete this. That I will do it independently. That I will do it independently. Let me take it separately. So I will add a resistor now, not to the circuit. Resistor. I will change the set the resistance to say ohm 540. Right, this is a 540 ohm resistor. Now I want to measure the resistance value, double check. So then I will, because there's no negative positive when it comes to resistance, you don't need to worry, just connect the two edges and change the mode to not amperage, change the mode to resistance. Then just click it because your volt multimeter can give you a small current and check the resistance, right? Okay. Now you need to start simulation. Of course, this circuit will operate. These are now two circuits. Okay. Right. You can see it's 540. 540. What was the actual value? Actual value is 540. Yes. Okay. Right. So now you know how to use your multimeter to measure resistance, voltage difference between 2 points, and of course, how to measure the current. So make sure when you measure current, you connect your multimeter serially. When you measure voltage, there must be voltage difference between those 2 points. Okay. And resistor, of course, you can calculate separately, independent. Right. So that's it for today. We have covered a lot. Right. We have covered a lot. And next day, next class, uh, this is how you do the continuity test. Continuity test will just give you a beep if there's a closed path. If there's no closed path, you don't need to give current. For example, now battery is not there. But if there's a closed path, that means your circuit is properly connected. And when you set it to continuity, it will give you a beep. Actually, it will send a small current and see whether you get the receive the current. Because most of the time issue is your circuit is not properly connected. Okay. So that is why this battery is now not used. Rather, of course, this is not going to light up your LED because this is not going to give you a big current, but it will check whether there's a closed path or the circuit is closed. Okay. That also you can do with your multimeter. Okay. Right. So next class we are going to look at the Arduino board and how to use the Arduino IDE and do a bit of digital electronic programming. Right. Digital electronic programming again. You need to do it in a physical manner, but we will do it in our tin CAD simulation environment. Okay. Right. So we'll stop at this point. Right. Thank you. Maybe next class we can do the same thing so that it's pretty much done, or maybe 75% done. And then we'll continue with our past paper discussion. Okay. So I think that is better. Next class also we will do this and then continue with past paper and do the rest of the stuff later. Okay. Right. We stop at this point. Right. If you have any questions, you can keep asking in the WhatsApp chat also. It may be personal message or you can use the group. Okay. Right. We stop at this point.
Thank you, sir.
Okay, you're welcome.